Yeah, hello, my name is Stenstrand. I'm working for the Global Skanska Competence Center in Finland, and my responsibilities are production BIM and 4D scheduling. I'm gonna show you some examples of what we have done in Finland and also some example of what we are developing now. So we're talking about production BIM. We have the production model that consists of all the architectural, structural, and MEP models. From the models, we have taken all the drawings, the reports, and our measurements for the prefabricator. At Skanska, we also do some modeling ourselves. We're doing the site plans, safety plannings, and some temporary structures. In some projects, we have used BIM models for supply chain management and purchase packages. And one big part of the production BIM is the 4D schedule. So with help of BIM, the communication between stakeholders will be much more efficient, as we heard in the earlier presentations. For example, the model is used on in site meetings to show, as here, some difficult spots for the MEP installations. The traditional way is on site to search the information from 2D drawings, from paper drawings, and a lot of time is spent on searching the right paper, the right drawings, and also a lot of time is spent on explaining for the doer how he has to construct something. But with the integrated model on site, we can easily show the difficult spots, we can easily show the information from the model, and as I mentioned, there is the architectural, structural, and MEP model all in the same place. So, production planning or the 4D scheduling, before construction starts, we have to define the master schedule. The project planner has to define the master schedule, and it can be shown in 4D using the models. To be able to create the schedule, the project planner has to get to know his project, to get the information he needs for the schedule, and that is all done using the model. Of course, he has to have the drawings as well, but he will very fast get a clue what the project is like using the model. The process how the 4D schedule is made is shown here. First, you get the quantities out of the model divided into locations. By connecting the quantities with the recipes, we get a schedule that is linked to the model. And by linking the objects in the model, we get a 4D simulation of the project. And when we have this 4D simulation, we can easily optimize the process. This is how it could look like after the master schedule is shown in the model. After that, you have to define the installation order, and that could be easily done in the model by just clicking the right order from the model. The result could be something like this. By showing this to the installation crew, they will know exactly in what order they have to install the elements. The model doesn't only show how or when to install the element, it also shows all the details. For example, all the rebars and connections with other structures. From the model we will get quantity information for site use. For example, if we have to cast some foundation one day, we can get just that information out of the model very easily. Or you can get a report which could be used when you're ordering when you're ordering elements from the prefabricator. What we're doing in Skanska, Finland, we're modeling the site plan using Tekla structures. This is an overview of one residential project. You can see we have the storage area, the waste containers, walking paths, and also the safety railings and the fencing. This could be very easily used to show the project to a new contractor or a supplier. Some temporary structures are also modeled. At the left you can see some element supports that are modeled into the model to show where they are and check if they are clashing with any other walls. At the right you can see the Crucell bridge, where the formwork supplier did model the formworks in 3D, and we connected them by using IFC to the model. Some collaboration have been done with the prefabricator, where we can get all the status data from the model or through the model to us. This is done by synchronizing the model with the designer and the prefabricator. When he then adds the status data, we can see it using different colors, like here. You can see the green ones are already done and the gray ones are already supplied. As Reet mentioned, we have in Skanska Norway used machine guidance very much in civil, and here is some example of that. By using GPS technology and some sensors, you will know exactly where you have your bucket, and then there will be less surveying needed on site. In Finland we have used some development in the use of model for surveyors, and we can get the information back to the model to compare the actual versus the designed. Another example of tested the laser scanning with excavation. At the left you can see the planned, in the middle the actual, and when you compare them you can see where you have to do some more excavation. When we started using BIM, we started with, so to say, the easy ones, the clash detection and the visualization. But when you start using it, you will always find more interesting ways to use the models on site. As we have the site plan, a lifting plan, some laser scanning tested, and this status data that I mentioned. And here is just some benefits using the model on site. There is plenty of benefits, but the greatest is of course the communication will be much easier. And another one is that the designer actually has to design all the spots in the building when it's in 3D. So he will actually see every spot and compare them with the other models. This will result in less mistakes done on site and less clashes. Also, the problem solving will be much easier when everyone knows what we are talking about, when we can show it easily in the model. And the information will flow all the way to the doer. And then I have a video from one of our sites where we have used the model. Could we get some sound also?
The production model is already in daily use.
Mulla henkilökohtaisesti se on päivittäin se 8 tuntia käytössä ja kyllä mä luulen, että tuolla työjohdolla on auki se päivittäin. No me käytetään sitä niin kuin työn ennalta suunnitteluun ja elementtiasennuksessa elementtien tilausta varten niiden listaukseen, raportointiin, mitä me tilataan ja sieltä saadaan kaiken näköistä sitten tietoa, korkeuksia, painoja, niin voidaan suunnitella nosturit ja muuta, mutta työntekijöiden kanssa pääsääntöisesti sen tekemisen visualisointiin saadaan hyvin selville se, että mitä tehdään. Parvekelinjaa tossa, niin meillä muuten täällä sama järjestys jatkuu, mutta siihen tulee tää pieli kummankin laatan alle. Niin ei voida asentaa.
Se on viimeinen. Se on pantava viimeisenä.
Niin on joo, koska toi V-talon laatta tulee sitten ensimmäiseen. Siinä on tuo leukapalkki. Sitten tää täytyy uittaa tonne asennuskolojen väliin. Kyllä sen helposti oppii. Tietysti se vaatii sen muutaman päivän opettelun näihin ihan peruskäyttöön, mutta sitä käyttämällä sitten sen oppii itsessään oikeastaan aika helposti. Tänne puolellehan me saadaan se massa, mutta toi täytyy vaan sillä neopreenikunnilla eristää tuosta laatasta irti. Kyllä se 3D tuo siihen aika paljon syvyyttä siihen suunnitteluun ja varsinkin se on suunniteltu kaikki ne raudotuksineen ja muineen, niin on siinä täytynyt suunnittelijankin huomattavasti pidemmälle suunnitella se ja ajatella jo suunnitteluvaiheessa. Et jos mä saisin valita, niin kyllä mä ehdottomasti ottaisin mallinnuksen seuraavalle työmaalle. Ei siinä mitään, niin jatketaan tosta.
Yeah. Here you can see the main benefits of the model. You can communicate through the model. It will make it much more easier. Yeah. Thank you.
Teeme ka selles blokis nii, et vastame peale kõiki esinejaid. Nüüd on mul hea meel anda sõna siis riigi kinnisvara esindajale härra Vaartnõule ja mul on väga hea meel, et noored vihased mehed vastates Margus Sarmeti küsimusele, et kuidas riik saaks aidata, viitasid sellele, et teid tuleks aidata. Nii et hea meelega kuuleks siis, kuidas riik võiks teid aidata, et meie saaks teid aidata.